Hello once more, grade 11s. Welcome back to another lesson of the Euclidean Geometry series. We are continuing with examples. So in this lesson, we'll be focusing on questions around cyclic quadrilaterals. If you are catching up, if you are joining for the first time, I will strongly advise that you catch up on the previous lessons. So without wasting time, let's look at a couple of tips before attempting to solve the 3 examples that I've prepared for this lesson. Okay, so very important. So it says here, number 1, bullet number 1, may not always be told that quadrilaterals in a given circle are cyclic. Okay, so one thing that I want to mention, especially when it comes to Euclidean geometry, I've mentioned in the last lesson that it's very important to read this problem statement. I will show you what is a problem statement and link what is what is given on the problem statement to what is there on the diagram. Very important to take note is that if you see that a line looks like a tangent, don't assume that it's a tangent. If you see that a point is a center, don't assume it's the center. If you see that, which one else? If you assume that a circle is a circle, don't assume that it's a circle, unless if they tell you on the problem statement that it's a circle. I hope you get what I'm trying to say. If you see that, some of them will come as I go on and on. But the only time, so there's only one exception. The only time you can assume or you can deduce that a shape or a figure is cyclic is if you see 4 points starting as the circumference of a circle. That's when you can say this is a cyclic quadrilateral. This is what this statement is saying. It says you will have to check the circle in your diagram to see if there are 4 or more points on the circle forming cyclic quadrilateral. So this is the only exception that we have. Even if that you see that this line is straight, don't assume that it's straight unless they're telling you that it's straight. Okay? But if you see a circle with 4 points touching the circumference, okay, no, they're not touching. Maybe let me draw another one. If you see something like this, even if they don't tell you that this is a cyclic quad, as long as these 4 points touching the circle are there, then that's when you can say it's a cyclic quadrilateral. Okay, it says mark off all angles in the same segment equal. Again, very important. So this is what we call the bow tie theorem. So if you have a circle there, you've got 4 points, so this point will be equal to that point will be equal to that point. Okay, so mark off all angles in the same segment. So this is what we call the bow tie theorem. So this are in the same segment, this one are in the same segment. Okay, very important. All exterior angles equals to interior opposite angles. So if this is a cyclic quad and we've got an exterior angle that is extended, mark off that immediately. Mark off equals to that angle, because we know that we've got a theorem that says the exterior angles of a cyclic quad is equals to the interior opposite angles. Okay, and remember that opposite angles of a cyclic quad are supplementary. Very important. So from here, this angle will be equals to this angle. I hope you are shouting there and saying, no, they are not equal. Yes, they are not equal, but they are supplementary to 180 degrees. So angles that are opposite to each other, they add up to 180 degrees. Okay? And then work backwards from required to prove. This is a very important tip or tool that we need to use. I will show you when I attempt the problems. Okay? We'll jump over now to the examples. Okay, example 1 reads as follows. The problem statement, it says A, B, C, D and B, C, D, E are cyclic quadrilateral. So here they are telling us, so we've got 2 cyclic quads in one diagram. Calculate the value of the unknown angles. Okay, so I'm going to start by marking off my cyclic quadrilaterals. So let's see if we can get a quick cyclic pen. So got one cyclic there. Okay, so that's the first one, and then the second one. Yeah, I think that one was too thick, but let's see how far we can go. Got another one there. Very important that you use different colors so that you can see what is happening here. Okay, now I can start solving the problems. Okay, so from here, and remembering what the tips were saying on the previous slide. So automatically when we see this, so we know that this angle plus this angle, when you add them, they add up to 180. This angle, okay, and then we can see that this is the exterior angle there. So you can see that this is an exterior angle. So this angle B will be equals to that. So this will be equals to that. So I'll just mark off with 2. Two lines so that we can see that that is equals to that, and then we'll mark off them as we go on. Okay, so as mentioned again in the last lesson, is that here when it comes to those work examples, I'm not really interested about writing all the nitty-gritties here, trying to impress the marker that okay, this angle is equals to that, that's the reason. No, we will do that as we start doing what you call geometric riders. When we attempt to solve previous exam papers, that's when we'll write like we are writing an exam. Here I'm just showing you the way of dealing with theorems and solving the examples. Okay, so just to recall that I call this a love letter. So very important that you read the love letter. You read it first, you read second time. The good thing about this love letter is that it's very short and straight to the point. Okay, I don't know what happened to my... Okay, sorry about that. My screen is acting up. Let's give it a second to come back. Okay, as I was saying, it's very important that we link what is on the love letter with what is there on the diagram. But the good thing about this one is that it's very short and sweet. Okay, so we'll start determining these angles. So, and so we've got A, we've got B, we've got C, and we've got D, and E. So those are the angles that we need to determine. Okay, so we'll determine them in alphabetical order. So, if you look at angle A is opposite angle C. And angle C is 100 degrees, and it's in A, B, C, D cyclic quad. So we know that this angle, when you add them, they add up to... Oh no, what's happening with this screen of mine? Yeah, we're blending, remember? Opposite that angle, so if this is 100, then therefore this must be 80 degrees, because when you add them, they must give you an 80. Very, very important and straight to the point. Okay, if you look at angle B, it's an exterior angle of cyclic quad CDEB. So the exterior angle of a cyclic quad is equal to the interior opposite angle. So this angle will be equal to this angle. So this will be 70 degrees. Oh my goodness. Okay, let's try that again. So this angle, as I was saying, angle B will be equal to angle, the small letter there, B, will be equal to this angle 70 degrees, because the exterior angle of a cyclic quad is equals to the interior opposite angle. So this is 80, so this is 70, and then C, where is C? C, again, if you look at this angle, so we've got a bow tie again here, as I was mentioning. So we've got a bow tie that goes in like that. So if that's the case, it means this angle there will be equals to that angle there. So A is equals to C, which is equals to 80 degrees. Bow tie theorem. Again, so if you look at your bow tie, it's like that. So this angle is equals to that, and that angle will be equals to that. So what is D now? D will be at the other side of the bow tie. If this is 30, then this will also be 30. So this is 30 degrees. Oh my God. Let's try that one more time. I am sorry about this. I don't know what's happening with this application that I'm using to record this, but it keeps on crashing and losing. Remember, bring everything on load shedding. Okay, as I was mentioning, we got this as 30, so this is 30, this is also 80. What are the reason there? Angles in the same segment, and we are left with one angle, which is angle E. How do we get angle E? So we already have this angle, we already have that angle. So C is what? C is 80, and then D is what? D is 30. So we've got one angles that we need to determine from this triangle. So E will be equals to 70. How do we know this? So if you add this and add that, and you subtract them from 180, you will get 70. How do we come about this? Angles in the same triangle, they add up to 180, or the sum of angles, the sum of the interior angles of a triangle, the sum of the interior angles of a triangle add up to 180. So you're gonna have something like 180 degrees is equals to C plus D, sum of angles of a triangle, sum angle of a triangle. There, C is 80, D is 30, and plus E. So you're looking for E. Then you solve for E. So this was basic algebra. E will be equals to 70 degrees. Straightforward, very, very easy. Make sure that you highlight your cyclic quad. You mark off the exterior angles, you mark off the interior opposite angles, you mark off angles that are in the same segment, and the rest is gonna be history. I have again apologize for the glitches that we had in this lesson, but I hope that this is not gonna deter you into enjoying these lessons of Euclidean geometry. We'll now move over to example number 2. Okay, we are now in example 2, which reads as follows. So we're gonna start by reading the love letter, as I always mention. Love letter. Read the love letter first. In the figure, ABCD is a cyclic quadrilateral. Okay, AB is parallel to DC in circle with center O. BC and AD produce mid at M, and D3 is equals to X. Okay, we've read the love letter first. We're gonna read it again and highlight all the important factors. ABCD is a cyclic quad, so that's my cyclic quad. A, B, C, D is my cyclic quad. So from there we can start looking at what is very important. So ABCD is a cyclic quad. What does it mean? It means the exterior angle is equals to the interior opposite angle. What does it mean? We've got an exterior angle again, which is equals to the interior opposite angle. What do we have? Opposite angles are supplementary. Opposite angles are supplementary. Very, very, very important. I hope you got all those 3 key factors. I'm going to erase and then we continue. AB is parallel to DC. Very, very important statement there. What do we know about parallel lines? Fun. I hope you can hear the noise that is coming from the background. It's kids who are having fun outside, playing. So even us, when you start seeing parallel lines, you must go and play and have fun. What do I mean by fun? F stands for corresponding angles are equal. So this angle will be equal to that angle. U stands for co-interior angles are supplementary. So these are supplementary. N stands for alternating angles are equal. Alright. So let's see our parallel lines. So this is our parallel line and that is our parallel line. Alright. So if you check this, we already have an F. We've got an F. So this angle will be equal to that angle. Again, if you turn this, we've got another F. This angle is equal to that angle. It's another F that is facing downwards. Very, very important. Also, what you can say is that this angle plus this angle add up to 180 degrees. Co-interior angles are supplementary. Very, very, very important. Again, I'm going to erase this. We continue. In the center with center O, what do we know when you've got center? The moment we've got the center, we must mark off the radii. This is equals to that. These two lines, are they forming any isosceles triangle? Yes, no, yes, no. There's no triangle that is going on. This is not a triangle. Neither is this a cyclic quad because it's a circumference. Okay? So that is not going to help us in this case. So we erase. That is how you analyze. That is how you break down the love letter. You know, you need to read those I love you. You need to read them step by step. You know, read the message. You know, see how this person is connecting with you. Alright? But if you look at arc, this arc, BD, it subtends an angle at center, okay, which is 2 times the angle at the circumference. So remember this. So in this case, we've got D, we've got A, and we've got B. So this arc subtends an angle at center, which is 2x at O1, the angle at the circumference, which is A. Very, very important. So which means this angle is 2x and this one will be x, depending on the size of this angles. Okay? So that's how you analyze the problem statement. Let's now solve the problem. Alright, show that MC is equals to MD. Okay, very interesting. How do we prove that these lines are equal? Let's go and check on the diagram. There's my MC and I need to prove that it's equals to MD. So I'm going to isolate this so that I can see it nicely, you know, so that I can dissect it nicely, so that I can see what is there and what is required. I've got M there, I've got C there, and I've got D there. I've been told that, I have to prove that this line is equals to that line. The only way I can do that is if I prove that this angle is equals to that angle, because base angles of an isosceles triangle are equal. But we know that the reasoning has been disbanded, or has been basically we're not allowed to say that base angles of an isosceles triangle. So never write a reason that says base angles of an isosceles triangle. So this has been discontinued. They no longer want you to write this. What they want you to write is the following: angles of an isosceles triangle. So that's how you can summarize this. I hope I will be able to in the future create a video where we just go through all the reasoning that are required from you when solving Euclidean geometry. Okay, so just keep that in mind and be on the lookout for that lesson, because that is something that I've noticed with Euclidean geometry. Most of the learners, it's not like geometry is difficult, it's just the reasoning, the complexities behind the reasoning It's what is giving you a time. Alright, so I need to prove that this angle is equal to this angle. Let's go and see. I've been told that D3 is equal to x. It was given to me there, D3 is equal to x. And I showed before that this angle is equal to that angle. Why? Because this is the exterior angle of a cyclic quad is equal to the interior opposite angle. And then from there I say, wait. I didn't just get this B is equal to x. I need to check what is this B equals to. Then I remembered my F of alternating angles. Remember, I've got parallel lines. So this angle will be equal to that angle. Therefore, C2 is equal to x. So I've managed to find that this is x, and I was given that this is x. If C2 and D3 are equal to x, it means indeed this line is equal to that line. Therefore, MC is equal to MD. Very nice question. Let's move. If D3 is equal to x, determine the value of M in terms of x. Very, very important. I'm going to use the same diagram. So I've got this as my x. I've got that as my x. I need to determine M in terms of x. What does it mean in terms of x? It means I'm not going to get an answer that says 20 degrees or 50 degrees. I must get an answer that says 20 degrees minus x, 100 plus x, 120 minus x. So it must be in terms of x. Okay? How do I get this? Sum of angles of a triangle. So I'm going to say C plus D plus M is equal to 180 degrees. What is the sum of angles of a triangle? We are now in grade 11. There's no need for me to show you all the steps. This is not an algebra lesson. This is a geometry lesson. So if this is x and this is x, it means M is going to be 180 minus 2x. Very, very straightforward. We move. Time wasted, never again. 2.3. Hence, what is the meaning of hence in mathematics? Hence means whatever that you got previously from the questions above, use it to prove or to solve a problem now. Hence, show that BODM is a cyclic quadrilateral. So let's go to our diagram and show BODM. BOD. We need to prove. How do we prove? Show this that is a cyclic quad. That is what we need to prove. Alright? How do I prove this? If I can get this angle, which is the exterior angle, is equal to the interior opposite angle, if I can get that this is equal to that, that will be the first answer. But the problem with that is that, yes, I can get this D1, but the question is, how will I get this angle B, this O, B, C? You know, how will I get this? It's not going to be an easy thing to do. That's one of the reasons why this angle, they didn't even give you a number. So they didn't even tell us that. Okay, maybe let me show you. Eraser. So you can see. So those are some of the hidden tips or hidden points when it comes to this geometry. Let me erase again so that I can show you. So the only way I can prove, or the way I thought I could prove, was that if I can get that this angle is equal to that angle, but I don't even know what this angle is. You see this OBC, and I was trying to show you that, you see, if they didn't even mention that this is B1 or B2, because they know that you can't get this angle in between here. Alright, so that option is out. So that option, what is it, deleting. So that option is out. Let me redraw again what is going on? Things are being deleted and colors are being changed. I don't know what's happening. So this is, remember, this is the cyclic quad, the imaginary cyclic quad that we need to prove. Alright, so the option of me proving that this angle is equal to that is out. So remember, if cyclic quad, you've got three options. So it's the one of exterior angle of a cyclic quad is equal to the interior opposite angles. Then there's one of opposite angles of a cyclic quad. Let's go and see. And again, this hence, as mentioned, it says use what you got in the previous question. And what did you get? We got that angle M is equal to 180 minus 2x. So that on its own it's a hint to say we need to determine the angle O1, so that we can say this angle O1, when I add it with angle M, it gives me what? 180. And if it gives me 180, then we know that these two angles that are opposite are supplementary. So we need to hunt for O1. How do I get O1? Remember, I had mentioned that this is X, right? It was given to me, and I had said angle A is equals to X. How did I get this? I got this by alternating angles. Not alternating angles, but corresponding angles. So I've got an F that is like that. Okay, so this is X. And I had mentioned that if this is X and then this is 2X, how did I get this 2X? An arc subtend an angle that is twice the angle at the circumference. Alright? So this is X, this is 2X. Now O1 is equals to 2X. Okay? Number 1. Angle M is equals to 180 degrees minus 2X. What is O1 plus M? O1 plus M is equals to 2X plus 180 degrees minus 2X. This will cancel that. O1 plus M is equals to 180 degrees. Then if O1 and M, they add up to 180 degrees, therefore, what can we say? BOD is a cyclic quadrilateral. Why? Because the opposite angles are equal. And that concludes this work example number 2. Let's pause for a second and recap. What did we do? We first analyzed the love letter. We link what is on the love letter with what is on the diagram. And then we discovered that we've got a cyclic quadrilateral. We went to the diagram to highlight all the points that falls under cyclic quadrilateral. Then we checked that, or we were told that AB is parallel to DC, and we applied the fun theorems, if you can call them. We check what is alternating, we check what is co-interior, and we check what is alternate corresponding. And then we went to the center and we mark off our radii as mentioned, that when you've got a center, just make sure start by marking off your radii, which is what we did. But we discovered that the radii is not giving us an isosceles triangle, but we discovered that from there we've got an arc which subtends an angle at center, which is twice the angle subtended at the circumference. So O1 is equals to twice angle A. Okay? And then from there we started solving the problem. What did we learn about solving that two lines are equal? Those two lines are going to form an isosceles triangle. And how do you determine that the lines MC and MD are equal? By solving the base angles. But remember, when you give a reason, you don't say base angles of an isosceles triangle, but you say angles opposite equal angles of an isosceles triangle are equal, because the the corresponding sides are also equal. Okay? And then from there we use the sum of angles of the triangles because they are formed under a triangle MCD. And then from there, how do we prove that BODM is a cyclic quad? We first mark off the points that they are telling us to prove, and then we know that there's an imaginary circle that is passing through those 4 points. And then because they say hence, we know that we have to use what we got in the previous question. And from there, we discover that we can't apply the rule of exterior angle of a cyclic quad because we are not given angle D1. We don't even know what is angle OBC. And then from there, we were left with one option of using angles in the opposite angles of the cyclic quad are supplementary. And that, ladies and gentlemen, concludes example number 2. I hope you are starting to get the hang of Euclidean geometry, and I hope you are starting to enjoy it like the way I'm enjoying. Let's now move over to example number 3, which will be the last example. Okay, we are now going to attempt example number 3, which says in the diagram below, O is the center of the circle. So from the word go, O is the center of the circle. So this is my center. So we know that this angle is equals to that angle, which means Q1 is equals to R1, and Q1 is given as X, which means this is X. Okay? Why? Because radius are equal and they make up angles, base angles that are equal, which is one of the properties of an isosceles triangle. Okay? Again, we've got angle at center is twice the angle at the circumference, so O1 will be twice P1. So you can see opposite angles twice the angle at the circumference. PQRS. Okay, so if they're telling us that there are points on the circumference, so we can see if there's a cyclic quad. TOQ is a straight line such that T lies on PS. Then PQ is equals to QR. So okay, it shows us there with two lines. PQ is equals to QR, and then Q1 is X as shown. Okay, now this is 3.1. Calculate with reasons P1 in terms of X. So what steps are we going to get what steps are we going to follow to get to P1? So I've already mentioned that this is X, this is X. Why? It's base angles of an isosceles triangles, angles opposite equal sides. Okay, so if this is X and if this is X, it means O1 will be 180 minus X, 2X. In fact, maybe let me do this. Get a pen that is light. Yeah, so this is X, so this is X, so that's X, therefore this will be X, which means O1 will be 180 degrees minus 2X. How did I get this? Remember, from the isosceles triangle, this side is equals to that. So we've got X, we've got X. How do you get the third side? Sum of angles of a triangle, which means this will be 180 minus 2X, which is the same as what I did on the previous example. Alright, now if this one is 1 minus 2X, what will be this one? So P1 will be half of O1. Why? Angle at center is twice the angle at the circumference. So it's a reverse. So that's your reason. So this is half. What is Q1? Not Q but O1, which is what I've determined before. O1, which is 180 minus 2X. And then if you simplify this, this was going to be 140 minus X. Okay, so P1 there is 140 minus X. Again, grade 11th. Here, the main priority of this work example is to show you how to attempt this problem. So that's why I'm not writing any reasons. I'm not writing like I'm writing an examination. We are still going to get to that. Alright? But what is very important is that as I keep on making this note, I keep on telling you the reasons. Why am I saying this is equals to that? So that you can get to the habit of giving reasons for your statements. Alright? So we've proved that, okay, we mentioned that this is 140 minus X. Okay? So 140. Just that this diagram is a bit small, so I can't squeeze everything in. Alright? Show that TQ bisects PQR. So how do we prove that a line bisects an angle? So let's see what is P. So PQR. So we've got the situation like this, and we've got the line. So we've got P, Q, and R. So the only way that you can prove that a line bisects an angle is if you can prove that this angle is equal to that angle. I repeat, the only way you can prove that a line bisects an angle is if you can prove that the angles in between are equal. Okay? So this line cuts the angles into two equal parts. So already I've got X here. I need to prove that this is X as well. How do I get there? Let's see what you have. if you look at this cyclic quad, so this is cyclic quad, so 4 points. All right, no. Okay, let me make some space for me here because there are a couple of calculations that I'm going to do here. Okay. All right, so this is going to guide us. Man, why did I get such a? So this is going to lead us with an answer. Right? So those lines are equal. So if you look at my diagram, and again, it's very important to isolate this diagram so that you can see them properly. So this is P. So this is P1, this is Q, and that is R. Alright? But this R has got something like that. So we've got an X there, and we've got R2 there. Alright? Then this one's meet there. So we've got X, and we want to prove this. So this is Q1 and Q2. So Q1 and Q2 there. Alright? Now, because these lines are equal, it means this angle must be equal to that angle. So P1 must be R. Why? Because base angles of an isosceles triangle, but that reason is no longer being accepted. So you need to mention that angles opposite equal sides. Alright? Because this lines form an isosceles triangle. Then P1 is equal to, what is R? R is equal to R1 plus R2. It is R1 plus R2. What is P1? P1 I've already determined it as 140 minus X is equal to, what is R1? R1 is X. What is R2? R2 is what I'm looking for. Okay? Therefore, R2, this is algebra. R2 is equal to, I'm gonna take this X on the right hand side to the negative side. R2 is equal to 140 degrees minus 2x. So I managed to determine this. I managed to get that one. Alright? From here, where do I go? So I got this one. Remember, I'm chasing Q2. Okay? Now let's look at this as, let's look at let's look at this triangle. So we are dealing with a lot of triangles here, and this is the only part I don't like about geometry, where your diagram becomes so messed up with colors and for you to be able to see. Alright, so we've got a triangle again. So this is the same triangle that I drew here. So I'm going to now sum angles of a triangle. So I'm going to say Q1 plus Q2, which is that and that, plus P1, which is that, plus R1 plus R2. They add up to 180 degrees. I don't have a space there. You can put a reason to say sum of angles of a triangle. Then I'm going to substitute. What is my Q1? Q1 is X. Let me do that. P1 is 140 minus X plus, what is R1? R1 is equals to X, and then R2 is what I got here, plus 140 minus 2X is equals to 180 degrees. Alright, so this 140 plus 140 will give me 180 on the left and 180 on the right. They will cancel, so this will cancel that, will cancel that. Minus x plus x, they will cancel, so this will cancel that, and then I'll be left with x plus Q2. And grade 11, I'm just showing you this for the sake of interest. From here it's just basic algebra. Okay, plus I'm left with minus 2x there is equals to 0. Okay, what is x plus negative 2x? It's negative x, and then I take x to the right hand side, then q2 is equals to x. Now I've proven that this is x, I've proven that this is x. If those lines, if q1, because q1 is equals to q2, which is equals to x, therefore tq bisects pqr. That's how we solve that this is a cyclic quadrilateral. I've done with 3.2. We are now going to 3.3. And again, apologies for the noise that is coming from the background. Okay, so it says show that STOR is a cyclic quadrilateral. Okay, so I'm going to clean up my diagram here. I'm going to clean up here. Why is this thing taking so long? Alright, okay, so it says I must show that STOR is a cyclic quad. Okay, I'm going to mark that so that we can see STOR. Okay, if this is the case, it means there's an imaginary circle that is passing there. Okay, there's an imaginary circle that is passing there. But if you look at this, I don't like this thick one. If you look at this, there's a it shows that this is going to be our cyclic quad. This is what this problem wants us to look at. And then if you look at that, you will realize that we've got an exterior angle. So it means this angle, if we can prove that this angle is equal to that angle, then we would have proven that STOR is a cyclic quadrilateral. Okay, so that is what we need to chase. Okay, so my question is, what is the value of S? We need to determine this S. How do we get this S? Remember, we've got this, we've got that, we've got that, we've got that, we've got that, but and we also have O1. So O1 we already have, I think it was something like 180 minus 2x. Okay, so we need to determine this S. How do we determine this S? Now again, we're going to look at another cyclic quad, a bigger one. Okay, let's get that. So if you look at that cyclic quad, we know that opposite angles of a cyclic quad are supplementary. Okay, so it means this whole angle, when I add it to this whole angle, it must give me 180 degrees. And I already know that I've got x there, I've got x there. My question is, what is S? So S is going to be, let me rather do this and say S plus Q1 plus Q2 is equals to 180 degrees. What is the reason there? Opposite angles of a cyclic quadrilateral add up to 180. What is S? I don't know. Plus what is Q1 is X. What is Q2 is X. And then that is 180. Therefore, S is equals to 180 minus 2X. Okay? So I managed to determine that this is 180 minus 2X. And before, let me erase, you can see what we've done. So I just got that this is 180 minus 2x, and here I determined before that this is 180 minus 2x, which means this indeed is a cyclic quadrilateral. Why? Because the exterior angle of a cyclic quad is equal to the interior opposite angle. Therefore, STOR is a cyclic quadrilateral. Very interesting question. Again, another question that I like so much about proving that a cyclic is quadrilateral. You have to follow all the basics that I've shared with you. Again, if you joined for the first time in this lesson, I strongly advise you to catch up on the previous lesson. Again and again, I strongly apologize for the noise that is coming from the background. But I hope that did not hinder you, and that did not deter you, and that did not prohibit you from following and going through this exciting lesson with me. Until we meet again, continue to take care of yourself, and we'll meet next time. Thank you.